Hi, my name is Denis. In this video we will model this beam system. First, let's copy all of the common commands to the new Mac file and enter our parameters. In ANSYS there are two finite elements for modeling 3D beams, beam 188 and beam 189. The first uses two nodes and is used for straight constructions, like ours, and the second is used for constructions with curvature. As opposed to link element, now we must specify the section. In common beam sections there are 11 preset sections, and in our case we need the I-beam. Let's specify the parameters according to our scheme. The sec-type command is used to set the sections for links, pipes, beams and shells. The sec-offset command is used to set the offsets for the last section defined. In our case, both offsets are zeros. The sec-data is used to set the data for the last section defined. In previous video, we created the nodes and elements directly, and it was the last time we used this method. From now on, we are creating the geometry with further meshing. This time, our geometry is one-dimensional, so we will create lines by key points. Let's mark our key point and line numbers. A quick note: the default active coordinate system in ANSYS is global Cartesian, so we are creating the key points and lines in this system. To display the numbers, tick them in numbering in plot controls, and then plot desired geometry elements. If you want to plot all at once, use multi-plots. We have to specify the section orientation for our lines. Let's mark the desirable orientations in our scheme. Let's open documentation for the beam element. As you can see, the element has its own local coordinate system, where local x-axis coincides with the vector tangent to the line. What is more important for us, the orientation key point must be on local z-axis. Let's take a look at these three schemes and try to figure out the position of orientation key points. For line 1, we can use key point 3, for line 2, key point 1. But for lines 3 and 4, we need to create a separate key point, which also can be used for the first two lines. All the line attributes can be specified in mesh attributes for all or picked lines. In particular, we can specify the orientation key point by ticking the box and selecting it. Let's try to figure out what is going on in our log file. The cm command is used to group selected items into so-called components. It would take a while before you realize the true power of this command. In our case, we will skip it and use a simple line selection with lcell command and set the attributes with lat command. After you finish, Don't forget to clear the active selection with all cell command. We have two options to control the mesh size manually. The first is to set the desired length of an element, and the second is to set the number of elements for each line. Let's set the number of elements, for example, to 100. To mesh all lines, click Mesh, Lines, Pick All. To see the shape of elements, go to Plot Controls, Style, Size and Shape, tick Display Shape of Element and specify the scale if needed. Let's set the boundary conditions. It's easier to select key points than nodes, so let's apply our conditions to them. All of the geometry laws will be automatically applied to corresponding nodes and elements before solution. But if you want to apply them explicitly, use Apply, Transfer to Finite Elements, All Solid Laws. To display the laws, go to Plot Controls, Symbols, tick All Applied BC, let's also select Surface Pressures, and press OK. Applying the pressure is a bit more complicated. If you try to apply it directly using pressure on lines, you will fail. Let me demonstrate it to you. As you can see, no pressure was transferred to the elements. There is a separate command for beams, called SF beam. As you can see, we have to select all the elements. And the last thing we want to do is to select 100 elements. And what if the mesh will be changed? Let's use the entity selection. First, we need our line number 2. And next, we need all the elements attached to this line. To understand the surface load key number for our load direction, we need the element specification again. In our case, pressure is uniform and directed against the local y-axis, so our surface load key is 2. Let's launch the solver. We already know how to plot the displacement diagram and specify the scale. Let's plot the graphs of inner forces and moments using the element table. As for the link element, the sequence numbers are in the beam element specification. The I and J stand for starting and ending nodes along the local x-axis of the concrete beam element. Let's set the element tables and plot some graphs. In this video, I didn't go deep into section modeling, non-uniform pressure and entity selection, so don't miss the next videos, press like and subscribe to the channel. Stay healthy!